Alrighty, so this time what we're looking at is some function, p of x, potentially the parent function, hence the p, and we're looking for where I of x is in relation to the parent function. Now, I of x is the parent function, but plus 3, so it's like 3 better. It's way better. But we're just talking about where it would be in relation to that. So, if we consider a graph, perhaps, basic x, y axis, let's put a little x there, a little y. The parent function, absolute value of x, looks a little bit like this. Oh, a bit better than that. My bad. I can do a little better than that. Okay, so it looks a little bit like this. Imagine that was a perfectly straight line. I mean, perfectly diagonal line. Imagine that was perfectly straight as well. But this is what the parent function, absolute value of x, would look like. Now, this new function I, it's the same thing, but plus 3. So if we wanted to kind of figure out what it would look like, we could look at, for example, at the point 1. At x value of 1, for the parent function, the y value is also 1. So it'd be right about here. But for the new function, for I, just colors real quick, it'll be 3 more than that. So we still are at 1, but now we're going to be at 4 for the y. 4, if we looked at, for example, the number 2, we could go out to 2 for the x, and that would give us 2 for the y. But if we do 2 for the x on the new guy, I of x, then we're going to be up at 5, which is cool. But look at what's happening here. At the same x value, the new one happens to be a bit higher. So when you've got this plus 3 on the outside, or anything being added or subtracted on the outside like that, we're translating our function vertically. So if this is a positive 3, then our function is going up by 3. If it's a negative 4, like if it said like minus 4 or something, then it would be going down by 4 units. So this, whatever number you see out here, it is a plus or a minus, and it's a vertical translation.